Welcome to Bethlahem Institute of Engineering. Bethlahem Institute of Engineering is affiliated to Anna University, Chennai and approved by AICTE, New Delhi. This institution was established in the year 2008.
Good morning, students. Today we are going to start our fifth unit. So under the fifth unit we are going to see about the first topic is blood gas analyzer. So we are going to discuss about blood gas analyzer. Okay. So this blood gas analyzer, this blood gas analyzer is used to measure the pH, that is the potential of hydrogen, then partial pressure of carbon dioxide and partial pressure of the oxygen of the body fluids with special reference to the human blood. So in this blood gas analyzer we are measuring the potential of hydrogen as well as the partial pressure of the carbon dioxide and partial pressure of oxygen of the body fluid with special reference to the human blood. So we are going to identify this pH, PC2, that is partial pressure of the carbon dioxide, and then PO2, that is partial pressure of the oxygen in the body fluid with reference to the blood, human blood. First one, pH, that is potential of hydrogen. So the normal range of this pH is from 7.35 to 7.45. So the normal range is from 7.35 to 7.45. If there is some alkalosis, it shows the alkalosis means increase in the pH value, due to the increase in bicarbonates. So if there is an increase in bicarbonates, there is an increase in pH value, it results in the alkalosis. Then acidosis. So if there is a decrease in bicarbonates which shows a decrease in pH values, and that condition is called acidosis. If there is an increase in pH value, it is called alkalosis, and if there is a decrease in pH, it is called acidosis. Then PCO2. What is PCO2? Partial pressure of carbon dioxide. So the normal range of this partial pressure of carbon dioxide is 35 to 45 mmHg. This is the normal range, that is 35 to 45 mmHg. So the increase in PCO2, that condition, if the level of this PCO2 is increased due to cardiac arrest, chronic obstructive lung diseases, chronic metabolic acid-base disturbance. These are the conditions for increase in PCO2. If these conditions occur, then that condition is called hypercapnia. That condition is called hypercapnia. Then PO2. PO2. The normal range of PO2, that is partial pressure of oxygen in body, is 80 to 100 mmHg. That is 80 to 100 mmHg. So here, if there is a lack of oxygen, that is the reduction in pressure of oxygen due to this condition, that is bronchial obstruction, blood vessels and hemoglobin abnormalities, that condition results in hypoxemia. So what are the four conditions? If there is an increase in pH, alkalosis; decrease in pH, acidosis; increase in PCO2, hypercapnia; and lack of oxygen, hypoxemia. These are the four conditions. So let's see one by one: pH, PCO2 and PO2. Before that, the basic principle of this. Okay, the basic so in this basic principle, this blood gas analyzer consists of 3 types of electrode system for the measurement. So we know we are going to measure pH, potential of hydrogen; PO2, partial pressure of oxygen; PCO2, partial pressure of carbon dioxide. So for measuring these all, we need 3 types of electrode system and a sample chamber. Sample chamber is mainly used for just placing the sample, that is blood. Okay, so here the sample is blood. Okay, so the electrode system and the sample chamber, these electrode and sample chamber are located inside a temperature controlled block. This temperature controlled block is maintained at 37 degrees Celsius, that is a human body temperature. Okay, so this electrode system and the sample chamber are located inside a temperature controlled block. So in the sample chamber, as I told, the blood sample is first injected into the sample chamber, where it undergoes a temperature equilibrium before measurement. So this will so the blood we know in this sample chamber we are injecting the blood samples. Okay, at that in the sample chamber, it will undergo the temperature equilibrium before the measuring of blood gas analyzer. Okay, next we see about pH measurement. Okay, this figure shows the pH measurement. Okay, in this pH measurement we are using 2 electrodes. Okay, this is on electrode, that is the measuring electrode, and this one is the next electrode, that is the reference electrode. Okay, so in this reference electrode, this is the reference electrode. Okay, so here silver or silver chloride reference electrode are inserted into KCl, potassium chloride solution. Here this is the potassium chloride solution. So the silver or silver chloride reference electrode is immersed in potassium chloride solution. This it is closed by a leaky membrane. Okay, this is closed by a leaky membrane. This leaky membrane is mainly used to permit the current flow from the reference electrode, from this reference electrode through the samples in the sample chamber to the measuring electrode. Just this leaky membrane just allows the current flow from this reference electrode towards the sample path towards the measuring electrode. Okay, in this measuring electrode, it consists of silver or silver chloride measuring electrode, which is inserted in a solution of constant pH, and it is closed by a glass membrane. Okay, this is the glass membrane. This is the glass membrane, which is sensitive to H plus ions. Okay, H plus ions. So as the samples pass through the chamber, the difference, so this samples, we know the samples is passing through the sample path, right? So as the samples are passing through this chamber, the difference in H plus ion concentration on either side of the glass membrane changes the potential at the measuring electrodes. We know the samples are passing through this sample path, so there will be some H plus ion concentration on both sides, here and here. So there will be some variation in the potential at the measuring electrodes due to this H plus ions. So the reference electrode produces a constant potential irrespective of H plus concentration in the sample. So the change in potential in the at the measuring electrode is detected by voltmeter, which has been calibrated in pH unit. So the pH is defined as logarithmically of the reciprocal of the value of H plus, that is pH is equal to minus log 10 H plus, that is equal to log 10 into 1 by H plus, that is the concentration of H plus ions. pH is the acid-base balance in a fluid. What is pH? It is the acid-base balance in a fluid. This is the pH measurement. Okay. So there will be two electrodes, reference electrodes as well as the measuring electrodes. This reference electrode is inserted in the potassium chloride solution, and then it is closed by a leaky membrane which permits the current to flow through the sample blood. Then due to the concentration of H plus ions in the sample, there will be some potential variation, and it is recorded by using the voltmeter. This is the pH measurement. Okay. Then we are going to see about CO2 measurement. Okay, that is partial pressure of oxygen measurement. Okay. So here the electrode system consists of two electrodes, that is the reference electrode and the other electrode. So here silver or silver chloride reference electrode which acts as the anode. Okay, silver or silver chloride reference electrode which act as a cathode. Then we are using a platinum wire. Okay, here this is the platinum wire which is used as a cathode. So here in this partial pressure of oxygen measurement, we are using anode as well as cathode. So silver and silver chloride reference electrode is act as the anode, and platinum wire is used as the cathode. Okay, so both of these are immersed in an electrolyte solution, placed in an electrolyte solution. Here this contains the electrolyte solution, and it is separated from the sample by a oxygen permeable membrane. This is the permeable membrane. Okay, this is the permeable membrane. Okay, so this is immersed in the electrolyte and it is closed by a oxygen permeable membrane. Okay, so a potential of 0.7 volt is applied between these electrodes. So between this electrode we are applying a potential of 0.7 volt. So the current generated by the system is measured by the CO2 in that sample. Current generated is the measure of CO2 in that sample. So we are applying an voltage or potential of 0.7 volt in between this electrode, and there will be some current generated in the system, and this current generated by the system, it is the measure of partial pressure of oxygen in that sample. Okay, so it is proportional to the quantity of the gas present in the blood. So this current generated, it depends on the quantity of the gas present in that blood sample. Okay, this is about CO2 measurement. So here we are using a reference electrode and a platinum electrode, which both of this is inserted in an electrolyte solution which is covered by the using an oxygen permeable membrane. Then we are applying a potential of 0.7 volt between this electrode. Then the current generated by the system, it is the measure of current generated by the system, and it is a measure of CO2 in that sample, and it is proportional to the quantity of gas present in that blood. This is about partial pressure of oxygen measurement. Okay, so here in this there is two types of measurement, vitro and vivo measurement. Okay, so in vitro measurement, the blood sample is taken. After taking that, the measurement will take place. In vivo means measurement is taken while the blood is flowing. Okay, flowing blood. The measurement of CO2 from the flowing blood, that is called vivo measurement. Okay, Next one, PC2 measurement. Okay, PC2 measurement. Here in this also, a silver or silver chloride reference electrode and a glass pH electrode is used. Okay, and this is glass pH. This is the glass pH electrode. It is immersed in an electrolyte solution and is separated from the sample by a carbon dioxide permeable membrane. Okay, carbon dioxide permeable membrane and a spacer. Here is the spacer which acts as the support for the aqueous hydrogen HCO3 layer. Okay. So the diffusion of carbon dioxide alerts the pH of the electrolyte, thereby changing the potential output of this modified pH electrode. Okay. So the diffusion of carbon dioxide alters the diffusion of this carbon dioxide alters the pH of the electrolyte, changes the pH of the electrolyte, thereby changing the potential output of the modified pH electrode. This gives the PCO2 in the sample. So okay, so the equation is H2O plus CO2 H plus HCO3, that is the bicarbonate. Okay, HCO3 is the bicarbonate. Okay, that is the measurement of PCO2. So here in this also we are using a reference electrode and a glass pH electrode. These two electrodes are immersed in an electrolyte solution and is separated by using a carbon dioxide permeable membrane and a spacer. Okay. Then the diffusion of carbon dioxide alters the pH of the electrolyte, changing the potential output of this modified pH electrode. Okay, this gives the PCO2 in that sample. This is how PCO2 is measured. Okay, this is the PCO2 measurement. So here in this blood gas analyzer we are measuring pH value, PCO2 value, PO2 value. Okay, hope you all understand. Thank you. If you have any doubt you can comment. Okay, thank you.